So there are a few other properties of functions that we can work with, and we're going to talk about a few today. Actually, something that wasn't always taught in the 8th grade, I noticed that this is a newer lesson included in one of the books that we utilize, and it's where they talk about finding the domain and the range and the x-intercept of a function. Now, that's not something that's tested on the 8th grade park exam, but it is something that we will learn later in the year when we're working with quadratics. So I thought it was a good time to kind of introduce those terms. This is the example that we're going to use to introduce these terms. Okay? We have the Ryder and the Diaz families. They are traveling home from vacation. At the start of their trip, the Ryder family is 200 miles from their home. They travel 50 miles every hour until they get home. The Diaz family, their information is shown in the table below, this table right here. So we are going to find and compare the x-intercept, the y-intercept, the domain, and the range. You know one of those already. We've already defined the y-intercept. We're going to define the other three today and figure out how to find them and what they mean in the context of this problem. So let's start by taking the Ryder family's information and putting it in a table. If I have an x and a y, an input and an output, what do you think would represent the input and what do you think would represent the output? Like, what would be the x and what would be the y?
X is 200.
X is
Zero,
x the
zero.
miles? Or is x the hours?
Hours.
Hours. The x will be the hours that they've driven. And that says hours. And then the y would be what? The miles. Great. So do we have values that we could put in?
Yeah. Y is the 200.
Okay, so 200 miles when? What would our x be there? 0. Because before they even started driving home, they had 200 miles to go. Then what happened after 1 hour?
150.
So how much is their distance now? 150. And then?
2 hours, 100.
Okay.
3 hours, 50. 4 hours, 30.
Okay, what about fifth hour?
Fifth hour, negative 50.
Negative 50.
Negative.
Nothing.
Why?
It stops.
Why?
Because they have no more miles to go.
Yeah, they're already home. They have no more miles to go. Once they got home, their distance from home was 0
You
miles.
got so
They were
disappointed.
done. So these are some definitions that we're going to write down, and then we're going to identify them. We can graph every function to identify, in addition to the table, what intercepts we're looking for. You do not need to add in the definition for the y-intercept because you already have it. The x-intercept is where our graph intersects the x-axis. Same concept as the y-intercept, except it's in a different spot. It's on the x-axis. We already know the y-intercept is where the graph intersects our y-axis. The domain is the least x value to the greatest x value. And the range is the least y value to the greatest y value. We'll talk about how to find those numbers and what they represent in context after we have those 3 definitions written down. Now, after you write the 3 definitions down, take a look at the graph and see if you could find the values that represent the x-intercept, the y-intercept, the domain, and the range. Because after you have these definitions, we're going to look at the graph and the tables to find those values. When we talk about the y-intercept, we know that it's where our line crosses the y-axis. How else could we explain that value? that y-intercept. It's our y value when x is 0. So how do you think we could explain the x-intercept? It's the value of x when y is 0. Absolutely. If you look on the line here, where is the x-intercept for the Diaz family?
5.
At 5. This is the value for x when y is 0. Good. Does anyone need more time to write down these 3 definitions? Okay, no problem. We are going to start to compare how to find these 4 values in the tables and the graph. You can get a head start on the graph when you finish your 4 definitions. Well, 3 definitions. You already have the y-intercept written. Can you see on the graph the y-intercept for both families? Can you see on the graph the x-intercept for both families? Can you see on the graph what the domain is for both families?
Yeah.
And could you see on the graph what the range is for both families? Good. We're going to talk about those numbers in just a minute. Are we good? Or we need another second? Okay, let's slide. So we're going to find all these 4 things. But before we do that, what do you notice about the change here? The rate of change is what kind of number if those lines are going down? It's negative. How can I change this situation so that my rate of change was positive? What would I have to change about this whole scenario so that the lines went up instead of down?
You have to travel miles. I mean, you have to go forward miles to the back.
So what would I have to change to the information?
You have to flip them.
You have to change the where he starts from. I mean, where he has to go somewhere instead of going. Yeah, going somewhere.
So maybe instead of coming home from vacation, they're going to vacation. That means their miles from home at the beginning would be 0. They would have started at home, and then they would have driven away if we kept our y value as the miles from home. What else could I change? Let's say they're still coming home from vacation. If I needed to change either the input or the output so that my rate of change was positive, what do you think I could change?
The bottom, you'll have to reverse it.
What do you mean reverse it?
Like put the 0 with 0, the 60 with 1.
But if they're still coming home from vacation,
Yeah, that's like
what's
2.
the issue?
That's like 2 to the house.
Like maybe you could say like right now they're at negative miles away from home, and they need to like go back to 0.
Can you be negative miles from home?
Mm.
I know
Yeah.
where your mind is going, and you're getting there. You are getting there.
Maybe instead of like going how far away, like how close they are to home, like maybe the distance from the vacation spot.
Yeah, maybe instead of tracking their miles from home, they're tracking the miles from the vacation spot, or maybe even just total miles traveled. At the beginning of their trip, if they haven't traveled any miles, that would be 0, and it would increase as they drove. Absolutely, those are ways that you could change situations, even if it's the same information. So now, let's start with the one we know, because we've done it before. Where in the tables would I find the y-intercept? Where x is 0. So our y-intercept is here. Where on the graph would I identify my y-intercept? On the y-axis. Good. Back over to the table. How about the x-intercept? Where y is 0. Perfect. That's our x-intercept. And how about on the graph? Where our lines touch the x-axis. Back over to the table. How about the domain? What is the domain? So the domain is actually the difference in our x values. So where in our table can I find that? The x. From 0 to 4. So what's my domain here? 4. And how about for the Diaz family? From 0 to 5. So my domain here would be 5. How about in the graph? I can see where the line began on our x coordinate and then where it's going. So 4 or 5, that would represent how we find our domain if I'm looking at a graph. How about the range in the table? The range represents what? Sorry.
So these y long to the greatest
Good, our lowest y values to our greatest y values. Where would that be?
the y.
Yeah, so from 0 to 200 would be our range. So our range here would be what? 200, good. And how about for the Diaz family?
300.
Completely, I'm sorry, last one, I forgot the graph. On the graph, the range, how would you identify it?
How like far it's going up from
Yeah, how far our y values are going. Here. That would be how to identify your range. Completely your preference, but which do we prefer to find the domain, the range, the x-intercept, the y-intercept? Do we prefer the table or do we prefer the graph?
table.
Okay, table. Some prefer the graph, right? It depends. What could the issue be with a table? If I need to find like the domain or the range specifically.
Because you don't always have all the values.
Every value might not be there. And you've seen a couple examples of that when we've had to find the initial value and do a calculation because it wasn't already on the table. So that could be a little bit of a drawback. I feel like most of the time you'd have those values, but you might need to see something else situationally. We already found the y-intercept. We found that it's 300 and 200, and we see it here as well. What does it represent in this situation? What's the context here? They're miles from home, absolutely. And what does the x-intercept, which we found here, be more specific with that? How many hours what?
Travel. I mean, how many hours took them to
How many hours traveled
To get home.
to get home? Absolutely. And how do we know that they're home?
Because they're at 0 miles.
Because they're at 0 miles from home, absolutely. Your y value represents miles from home, and once it's 0, they're there. Okay, the domain. We found it. Okay, the domain for the Ryder family was 4, from 0 to 4, and the Diaz family was 0 to 5. What does the domain represent? What's the context of the domain? How many hours it took them total? Absolutely, that was how many hours it took them. And how about the range? When we found that 0 to 200 or 0 to 300.
How many miles it takes.
Yeah, how many miles it took them to travel. Absolutely. Okay. Why are the domains and the ranges different?
Because they start at different miles.
So the family started at a different number of miles away from home. Okay, what else?
The X of
What about it?
the X has to you have to check for the X on the x-axis and then the Y on the y-axis.
Okay. So you can explain the difference in their ranges by what Sarai said. They're a different number of miles from home. How could you explain the difference in their domains? What do you notice about the lines and their shape? They're not parallel, which means what?
They're gonna intercept.
Are they going to though? Because we have
No.
Oh yeah.
no, they have. This is the relationship. There's no other portion of this line. Right, we're done. They started this many miles away. They drove. They got home. So we're done. The lines aren't crossing. Yes, if the lines went on forever, they would. But this is a situation. So there's context. Our lines don't go on forever. But what do you notice about? You said that they're not parallel. So what does that mean about the way they're moving? Correct. In this situation, they're not going to touch.
One of them is going faster than
One of the families is driving faster. Who's driving faster?
The Diaz.
How do we know? By just looking at the graph that the Diaz family is driving faster.
The line is steep.
Their line is steeper. Yeah, and if you look at the table, you can see the exact speed that they're traveling. How fast is the Diaz family driving per hour? 60. And how fast is the Ryder family driving? 50. Absolutely. So the Ryder family, yes, they're closer to home. They're going 50 miles an hour. They're still getting there sooner because even though the Diaz family is driving faster, they're farther away. So we're going to try this one. I'm actually going to pause the video. So we have two functions. We're going to use what we've just learned and use the definitions, that'll help you, to figure out this information. So we have two delivery services. We have delivery service B, we'll refer to them as Blue Apron, my favorite.
I like Blue.
Blue Apron.
Company that gives the send you.
And then we'll say delivery service A is HelloFresh. These are companies that deliver meals to your house, like boxes to your house so you can like make food. We use Blue Apron and it's the best. So these are two companies. This equation represents the total monthly cost for the food service. So Y is the total cost in dollars and X is the number of meals delivered. Information that is necessary. Subscribers can order between 0 and 20 meals each month. You are going to find the y-intercept, the domain, the range of each function. You're also going to find the x-intercept, but one of them doesn't have one. And I would like for you to explain why. I'm going to pause this video very quickly.